In this question, we have to find the distance between the 2 points negative 2, 5 up here and 3, negative 1 down here. So for negative 2, 5, remember you go over 2 and up to 5. For 3, negative 1, you start in the origin, come over 3 to the right and down to 1. And that's how you locate the 2 points. So whenever we're doing coordinate geometry problems with points, my advice is to label the 2 points before you begin. So if we call the 2 points, if the points are negative 2, 5 and 3, negative 1, then label these as x1, y1 and x2, y2. Now that's a very important point. It's easy to overlook it, but if you don't do it, a lot of people get mixed up later on when they're completing the formula. Okay? So our formula for the distance between 2 points is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's the difference between the x's squared plus the difference between the y's squared. So let's start to fill that in. Now do this step carefully. It's easy, but do it carefully. So x2 is 3. You don't want to make any mistakes here. Minus x1 is negative 2. So it's going to be 3 minus negative 2. So 3 minus negative 2 is 3 plus 2. Plus between the two parentheses. y2 is negative 1 minus y1 is 5. Okay. So d is equal to the square root of 3 plus 2 is 5 squared, plus negative 1 minus 5 is negative 6 squared. So just be careful with your arithmetic here. So 5 squared is 25, plus, now negative 6 squared. Be really careful about this. Negative 6 squared is positive 36, so it's going to be 36. Okay? And therefore d is equal to the square root 25 and 36 is 61. Now, that is the actual answer. Okay, that's the exactly the correct answer. But to get an idea of what that number actually is, we can use our calculator. And we can look up the square root of 61. Square root of 61. So 7.8102, now correct to, let's say, 2 decimal places, that would be approximately equal to 7.81. Okay, so d is approximately equal to 7.81. Okay, so that's the exact, and this is approximate. Okay, if you're in any doubt as to which is required, probably you should give both. Okay. Now, just briefly, that's the question done. That's everything you're asked to do. But just briefly, if we look at this, we'll see how the formula works. So if you bear with me for a few minutes, what we've done here really is we've created a triangle. So we've gone across the top like that, and then down the side like this. Okay, and you can see that what we've done here is we've created a right triangle. Okay, we've created a right triangle. Okay, and this distance here is the change in the x, and this distance is the change in the y's. So we're really using, if this is now the hypotenuse, what we're really doing is we're saying that hypotenuse squared is equal to the first leg, which is the delta x squared, plus the second leg is delta y squared. Okay, and then the hypotenuse, which is the distance between these 2 points. Well, if that's hypotenuse squared, then to get the hypotenuse we would take the square root. So it would be the square root of the x's squared plus the square root, plus it would be the square root of the delta x squared plus delta y squared. And that's where the formula comes from. Okay, now you don't need to worry about that, but hopefully you can see that this is just a very useful application of the Pythagorean theorem. Okay?